and the topic of today's episode is about he has designed distributed job scheduler in his work that he has been doing regular basis. So we'll be talking about that topic today, and there are lots of things that I'll talk about, and I'll tell you how the I'll tell you about the agenda and what all we are going to do. Before that, before we actually start with the agenda, I would request Snehasish if you can just talk about him and what you have been doing, just like an introduction, if you can give.
Sure. Thank you, This, for the introduction. Hi, folks. My name is Snehasish Roy. I'm currently working as an SDE at PhonePe. I have around just to give a brief introduction about myself. I have around 9 years of industry experience, being worked with other FANG companies like Google and Amazon in the past. Right. So currently, as part of PhonePe, I'm part of the core platform team here at PhonePe. And during my work at PhonePe, I had the privilege of working at Clockwork, which is our distributed job scheduler platform. Right. So in this session, we will explain to you how we have developed Clockwork from the ground up. Right. So we will, like how we do a typical system design into. We will go and build Clockwork from the ground up, and we will take your questions as well. So yeah, that's a short intro about me and the rough agenda. So back to it.
Cool. So thanks, Snehasish, for taking out time today. I think it's going to be a very valuable session because it's going to be it's a very common topic also, right? Like both asked in interviews as well as any system that you build, any product that you build. I think this kind of system is needed almost everywhere, right? So yeah, before we actually start with the actual agenda, I want to just call out that this podcast is actually sponsored by Engine Bogi, and Snehasish is also an expert over there. So if you want to connect with him, we have already put our link of Snehasish's profile on the description. I'll also be posting that link soon over the chat. So if you want to book a session in a one-on-one fashion with him, you can definitely go ahead and book it. With that, let's start with today's agenda. So what we'll do, we will start with the Snehasish topic, and Snehasish will be talking about all of those details for some time. And once he's done, towards the end, we'll take your questions. And in between, whenever you have any question, anything to ask, feel free to put it in the chat, so that whenever we start with a Q&A, we can start taking up a question. So don't wait to ask your question in the chat. Keep putting them, but we'll take them towards the end. So with that, let's start. I'll give the stage back to Snehasish.
Sure. Thank you, Udit. Yeah, as Udit mentioned, right? Like, please feel to ask your questions during the session itself. I will take regular pauses during, and will, go through the questions if you have any. Right. So let me share my screen. We will go through the blog that we have written. Right. So yeah, let me go through the blog that we have written. It's available on tech.funpay.com, and it talks about the work that we have done to build a blog. But we will go through the this blog will be our reference point. Right. So let's first begin with why do we need a job scheduler in the first place? Like, what's the role a job scheduler is performing in your day-to-day activity? So one of the use case that we have in PhonePe is, like, for example, the kind of merchant settlement that happens, right? So typically what happens in any UPI is, like, you make a payment, right? Like, you had, for example, when you pay a merchant, let's say 10 rupees, the amount is not immediately settled. It settles in a batch wise, like some after some time, let's say, for example, at midnight or every day, every T plus two, it depends upon the agreement. But yeah, it's not synchronous, or it's not immediate. So, for example, let's say you want to do the merchant settlement every day. So how will you do? Right. So either you will like to have some kind of a cron job or something that can, like, for example, if you have thousands of merchants daily, right, like thousands of merchants in your system, and you want to settle their account, saying that, hey, how much money do I have to, settle in their bank account? So you can, you have to do some kind of an scheduler. You have to maintain some kind of scheduler in your service. But it's not just merchant settlement. There are other services. For example, coupon is another good example. So whenever you have made any kind of an payment in PhonePe, you must have received some kind of coupon and all coupons have some kind of validity associated with it, right? It's like, for example, month end, 31st of March midnight, right? Coupon is valid. So how will you do the invalidation? So that is a time specific for each coupon, as a time is specific to it. So if you want to invalidate the coupon, you can, run some job. You have to run some job to invalidate to the user, saying, like, you have to send a push notification to the user saying that that coupon has expired, right, at some specific point in time. So these are some of the kind of jobs like that needs to be scheduled at a periodic interval to all the, for all the users. So for all the teams there, we have such kind of requirement. So one way was key, okay, each team would, you know run their own kind of scheduler in memory or do some kind of thing in themselves. But this is a kind of a common, problem that each team would solve. So there would be lot of redundancies, lot of duplicate work that each team would try to solve. But given that we are we work at platform team, our task is to make their life simpler and see if there can be a common platform component that we can provide to our internal teams, that that can leverage that platform and avoid the work, like avoid the duplicate work. So this is where Clockwork comes into place. Like Clockwork is a platform as a, like, it's a SaaS product, you can imagine, where teams come in, and they can say that, hey, I want to schedule a job. So let's dissect what is a job. So job, for example, in our case, it's just an HTTP callback, right? It's nothing fancy. We don't support running any arbitrary jar. Like, for example, if you want to run a Java code at this specific point in time, no, we do not support that. We just provide an HTTP callback, which the client has provided when you want to, when they were scheduling the job. So the callback or the param that they can provide is, like, they can specify the HTTP verb like get, post, put, whatever they want to do, and any kind of params they want to provide, and we will, while making an HTTP, we will honor those, right? So it's up to the clients what they want to be, reminded of, and our task is to just make that HTTP callback at the time they wanted it to happen. So if, let's say, somebody wanted that job to be executed at 5 p.m., so it's our task to make it close like to 5 p.m. Like, there can be some lag, but our task as a platform company, our task is to reduce that lag to bare minimum and to run it as close as possible, right? But as production system, yes, when there are, let's say, there is some kind of an huge search of events and huge backlog, there can be backlog. So our task is to reduce that backlog to as minimal as possible, right? So with that said, let's talk about the scale and the challenges, right? Like, so given PhonePe has 500 million, reached his 500 million active users, right? So our RPS to the system is again very huge. We serve, like, our Clockwork team receives around 100K job schedules per second, and this is just schedule, right? Like, for example, clients can say that, hey, I want to be scheduled, I want my callback to happen at 5 p.m., but it's not required that the job schedule is equivalent to the job execution. So these are two different components. One is scheduling and another is execution. So these are completely asynchronous event. We don't block the client until and unless, because job schedule can happen hours or even days or weeks after the job schedule has happened. So we, just to give you an idea of scale, we do about 100K job schedules per second with single digit millisecond latency, right? And at P99, our system ensures that there is no lag in job execution. And our target is key. Our uh, internal target is SLA that we are trying to keep is key. All the job callback should happen within 60 seconds, right? So let's see on how we are, approaching the problem. So this, let me share a whiteboard with you. So just to give you an idea. So for example, if, let's say, client comes, they kind of, okay, I have this, sorry, let me explain this here. I have this architecture or interaction diagram with me, right? So whenever a client comes, right, they schedule a job. This is a schedule part. Ki, hey, can you set me a reminder for this endpoint they will provide, and client and Clockwork will.
Nessie, sorry for
Yeah,
interrupting. Can you just zoom in a bit? I think screen is little smaller. That would help.
sure, sure,
Yeah, that's help. Thank you. That
sure.
works.
All right. So a client comes, they say that, hey, I want to schedule a job at this specific point in time. They will provide the HTTP callback. They will provide the time details as well. Just for the brevity sake, I have eliminated all the panels that the client provides. But the idea is that they will provide an endpoint and they will provide a time. And we will store all the job details in our database, primary database, which is HBase. I will come to the fact why we have chosen HBase and why is like how are we leveraging HBase. But yeah, just park it for a while. Our primary data is HBase, and then we give an acknowledgement back to the client after the storage is done. Then yeah, that acknowledgement will pass back to the client. Now what happens in the background? So Clockwork runs a loop. Like for simplicity's sake, you can run, imagine it's a poller that is running every couple of seconds or every second, that queries HBase, that performs a scan on HBase, like between some time. Let's say you provided a timestamp. I'm eliminating a lot of details here, but for simplicity, you can say that it is querying the HBase, saying that, hey, between this time range, let's say from current is 311, so between, let's say, 311 to 310, is there any job that needs to be executed, right? So and then it will find the list of jobs that needs to be executed, and then the HBase will give the list of pending jobs that are to be done. And then based on those jobs, let's say we have a batch size of 5,000, right? Because it can so happen that at midnight there are million jobs that needs to be executed, but it's not possible to get all the million results at once. So we do kind of an internal pagination or batching, like ask HBase to give us the result in a specific batch size, and then HBase returns us a specific batch of, let's say, 5,000, right, or 10,000. It's configurable, and then based on that batch size, what we do is we push to RMQ, because see, there are 2 points. Like execution is an asynchronous process, because like we have to make an HTTP callback to a different system, which is again an outside, like external service. We don't know whether that service is up or down, right? So it can take order of seconds, or well, it can take 10 seconds as well. So we don't want to block our scans just to make an HTTP callback. So we push all our eligible jobs in RMQ. So this is our RMQ. We push all our jobs to RMQ, and then we delete the jobs that we have just pushed to RMQ from HBase. So I will come again like why we have done this deletion as well. But whatever, like just an idea is ki we found the jobs that needs to be executed, then we delete, push those messages to the RMQ, delete those messages after the push is done, and then we repeat this process again and again. Then there are some consumers that are listening on the RMQ, and then once those consumer receive any messages from the RMQ, it actually makes the HTTP callback to that client, and then the response is registered and logged for analytical purpose. All right. So this is a very rough idea. I'm going to take a pause here and go back to it if to see if there are any questions.
So one person has a question, which is I'm not sure his name. His name is showing as devcast, but the question is any constraint around minimum granularity interval schedule for a job? Did you have any granularity around it?
Okay, okay, that's a fair point, right? So we don't have any specific like by granularity interval, like so clients can schedule job at any point, so they can specify the up to a second level granularity if they want. Okay, if they say okay, 3, 11, 50 seconds, something like that, they can also specify. But it's up to our system. Like for example, if we are running a puller every 2 seconds, 3 seconds, something like that, so it can the job, there can be some lag in polling the job, but yeah, they can specify up to second level granularity. So there is no bucket level, like we don't restrict the client to minute level or hour level.
Understood. I also had one more question actually from my side,
Mhm.
which was around. You said like every 5,000 you are just every five. I mean 5,000 page number you are fetching at a time, right, from the HBase. So let's say if you have million items, and it will take some time for those
Yes.
to be taken up all of them, right? So how did you figure out that okay 5,000 is the right number? Did you do any POCs around it, or
Yeah, that's a fair point, right? So I will come back to how we scale, right? So
Okay.
this is all about scalability. How are we achieving? Because as I mentioned earlier, our scale is 100K job schedules per second,
Right.
right? So
Right.
just doing 5,000 anyways is not going to happen, like it's not going to work for us, because that will require around like 20,000 20 batches, right, just for 1 second, and you can assume the lag will build up over the
Correct.
time,
Correct.
right? So I will come back to how we have achieved scalability,
Okay.
but like yeah,
Sounds good.
so, yeah.
Thanks.
So
Let's proceed. Yeah, there are no other
yes,
questions.
sure, okay, all right. So let me explain why have we chosen HBase and RMQ, right? So folks who don't know what HBase is a key value database, white column database, right? So you put a key, you provide a row key, like it's a key, and you provide the value associated with that key. And one good advantage of HBase is it provides sorted, like whenever you are storing the data, it keeps the data in a sorted order. Like the key is always in a sorted order, and this is a very like imagine it's a priority queue sort of, like based on the row key, it's always stored in a ordered manner. And if you just can relate to it to our use case, because we want to always execute the job in order. If a job is supposed to be executed at 4 p.m., right? So and there are two jobs, let's say 4 p.m. and 5 p.m., so it's always the case that the 4 p.m. job will be picked first rather than 5 p.m. job, right? So we there is an implicit our functional requirement as an implicit kind of requirement with ordering. So let's say if we choose a database with which does not keep the data in order, or if we have not chosen a proper database, then it would be kind of detrimental to our performance. So but since HBase keeps the index, like whatever the row key that we have chosen or the primary key that we have chosen in index in sorted order, that was helpful for us, because we can this is our requirement. We want to pick jobs in the order in which they were supposed to be executed, right? So using HBase allows us to efficiently query for rows by specific key and run scans based on a start and stop key. So what HBase supports is you can provide HBase a range query. Okay, this is my start key and this is my end key, and HBase will provide like can scan any all the keys, can provide all the keys that are between this range. So as I mentioned earlier, our poller runs every couple of seconds, and they try to fetch jobs between a specific range in the past. So for example, if current time is 318, it will run and find all the jobs that are supposed to be executed between, let's say, 317 and 318, because it is like if the current time is 318, we are damn sure that we want to run. And like let's say if there is a lag in the system and we could not process all the jobs that were executed at 317, so we have to pick the past jobs as well. So we do a scan between a specific time range in the past, not in the future, but in the past, and say that, hey, give me all the keys between a specific time. And since HBase has stored the data in order, it's very easy for HBase to return all the keys that match a specific that lies between a specific range, and return all the keys associated with it. Uh, then what else? Yeah, RabbitMQ. So RabbitMQ is our messaging broker. It's very similar to Kafka. If you have used Kafka, it differs from Kafka, but yeah, it's based on an AMQP protocol. It's so Kafka is on a pull model, but yeah, RMQ is on a push model. So whenever you push a message to RMQ and there are some consumers listening to it, so it's the responsibility of the RMQ to push that message back to the client or the consumer that is listening. So it's not the responsibility of the client to poll, but it's the responsibility of the RabbitMQ cluster to push the messages, right? So it's a messaging broker. Let's deep dive into the architecture. So we have cleanly divided our application into 5 modules, and during this session I will explain each and every module in detail. So first, let's begin with job acceptor module. So we have 5 modules: job acceptor, job extractor, RMQ publisher, RMQ consumer, and the leader elector. So just a brief about each module. Job acceptor is, as the name suggests, is the responsibility of job acceptor is to just accept the job requests that are coming from the client. So is this is the only module that is client facing. Clients only interact with this module, and the job acceptor just pushes stores that message in HBase and just gives an acknowledgement back. It does nothing else. It just takes a request from the client, stores the message in the HBase, does some validation and everything, and then returns an acknowledgement back. Job extractor is our asynchronous module that is running every couple of seconds in the background. And then what it does is its responsibility is to find the jobs that are supposed to be executed, that are basically eligible for execution. So for example, if the current time is 5 p.m. and so its responsibility is to find the jobs, all the jobs that are supposed to be executed at 5 p.m. It will do the filtering. Its responsibility is to find the jobs. Then RMQ publisher. So job extractor module interacts with RMQ publisher. Like it, let's say it has found, let's say, 5,000 jobs. Then what it does is push all those 5,000 jobs to RMQ, and then deletes the messages that have been pushed from HBase, and then repeat the same task again and again. RMQ consumer module is again very independent. Its responsibility is just to listen to the messages that are present in the RMQ queue, and does perform the HTTP callback. So in the RMQ message, you can imagine a message will be pushed, and the details of the HTTP callback is pushed. Okay, this is the HTTP endpoint. This is the params. You need to do this, and RMQ consumer will do it. Leader elector. Leader elector is sort of our coordinator, and this is the way we have scaled. So this is a very important module, and this is actually a very which is applicable for any distributed system. For example, I will come and how we have designed leader elector, but it's our brain. It determines it's responsible for scalability, partitioning, sharding, and everything. And this is our core module, and this is what has allowed us to scale beyond 100K, or we can even go above 100K just by adding more nodes, more partitions. And leader elector is the one which allows us to go beyond that. Right. So, yeah. Job acceptor. As I mentioned, job acceptor is the client-facing module. It's just responsible for accepting the client request, persisting the job details in HBase, and returning the acknowledgement back. Right. I'm going to take a pause here. Let me know if you have any questions for me.
There are multiple of them.
Yeah. Okay.
So, so there's a common question which is around the retry. So, what if, let's say, the
Okay.
HTTP callback to the client that you're going to make from the, I think, from the publisher side.
Okay.
Uh, if it fails, will it retry? Or if you're already going to cover later on, maybe we can park this
Yes.
now. Okay,
Yeah. So that's a good point. I have made a note of it in the and I will cover that. It will be covered in the RMQ consumer part. Yeah.
sure. The another question is, did you also look at some sort of a delay queue mechanism to schedule a job instead of using a poller?
Okay.
Maybe sorted set in Redis, maybe with the score as timestamp.
Yeah, that's a fair call out. See, it can work, but you have to understand the scale. For example, this does not work. So delay queue has always some kind of limitation. Like you can only schedule like based on the cluster that based on the queue cluster. Like for example, RMQ, they always have some kind of limitation. For example, like to the way you can delay the message to the while pushing, or like, before that message is visible to the consumer. So it's not necessary that you know it can work at our scale, because we schedule a job in the order of months in advance. For example, in our case, if we look at our production, it will be somebody has scheduled a job that will be executed, let's say, next year, right? So delay queue won't work in this case because it does not allow for that much granularity. It can work if you know that okay, you want to delay the job up to minute, or 15 minutes, 13 minutes, that can work. But given our scale, which is 100K job schedules per second, and our requirement that you have to you know schedule jobs year in advance, then the math, or it does not work. That scale can't handle.
Understood. Thanks. Let's go to the next question. Sorry, this was from my side only. This one is so when you were talking about that timestamp thing, right? I remember
Mhm.
at that time it came in when you were talking about HBase and timestamp thing. So actually, a couple of questions came at that time. So first, at that time that came was, so is it like an LSM tree indexing? I mean, that's the
uh
question the person is trying to ask.
Okay, so LSM tree is just a way of storing your, I won't say it's similar. Like, see, HBase internally uses whenever you store any, like, whenever you put any key to HBase, right? LSM tree is the way in which any database actually stores, like, it's kind of the way the database actually stores their metadata or the indexes in memory, right? So we are not actually building an LSM tree, like, if that's the question. I'm not sure what the question was about, but HBase or any database, let's say even if we are not using HBase, our main requirement of using HBase was it's a fast put, like fast key value storage, which supports fast get input request, and it supports scan. So any database that can do that. One example of it is Apache Cassandra, right? Cassandra also support this kind of query, and Cassandra can also fit in our requirement. It's just that we already had HBase in our production system, or we already had expertise around maintaining HBase in production, so we went with HBase. But if, let's say, if somebody is starting new, and they have options available, so any database that supports fast get input request, and support scan queries, and is horizontally scalable, then it can work. So Cassandra is one of them. There can be others, but yeah, Cassandra is one of them, and it's up to the database to how they want to actually store it. So if they are going with LSM, then it's fine. But the requirement of ours is, as I mentioned earlier, they have covered that.
Right. Another question I think is similar. You have already answered though, but I'll still highlight one. So it's person is asking why HBase not Redis. I think
Yeah,
as you already said,
because
yeah. Sorry, go ahead.
scans, yeah,
Yeah.
scans are not supported on Redis. It's just a key value storage.
Right. There was another one on the similar thing that he's saying Weber is saying same we can do via Apache
Mhm.
Flink.
Yeah, so that is just, I think that was analogous to the RMQ part that I have covered, right? Yes, you can use any of the queuing mechanism that you have. Like Kafka can also work, any Pulsar, Flink, whatever you want. It's just a way, like, since we already had RMQ in production at that point, and we had expertise around it, then we went ahead with it. Also remember that there are operational costs associated with it. So it's just not that key, yes, I can use XYZ database, anything can work, but there are operational costs, like, that are hidden to a developer. Okay, just because there is cost running to a service in production, right? So you have to also keep that in mind.
Right. Another one is around how HBase maintains the ordering. Is it
Mhm.
timestamp based keys?
Yes, yes. So, our row key or the HBase, the HBase has a value, like like column, that is row key, right? So our row key is client ID, comma, like client ID and the time associated with it, right? So client ID, partition ID, and the timestamp, right? So I will explain to that how we are doing that like to scale. But yeah, timestamp is one of the core component in the row key, and that is how we are doing a scan.
Got it. I think other questions are the next question is similar. What happens if the client is not able to, take the push or is not available? I think you're already going to anyway going to explain it.
Yes.
Um, Another question is from Praveen. He's saying, how long does the job details metadata is stored in HBase? Is there any archival deletion expiration policy? How does that work?
Yes, that's a fair question. So generally in production, in any production system, there will be some kind of an, I would say, audit that is required, right? So typically we never immediately delete anything from production. Everything has some kind of a TTL. So based on the TTL, you can just HBase supports setting up a TTL on a specific key, and based on our compliance and audit requirement, we add that TTL before like whenever a client has said key, I want to delete this job, we never immediately delete it. We update the TTL based on our policy, and then it's get automatically deleted after the TTL is expired.
Makes sense. Last question from the list as of now. Instead of ingesting jobs to HBase first, can job acceptor not directly send it to RMQ?
Listing jobs to HCAN job acceptor, not directly. Okay. Job acceptor is interacting with RMQ publisher, and which that is sending to RMQ. So I'm not sure what's the question
I
like.
think the person understood that job acceptor is taking the element, giving it to HBase, and then somebody else is giving it to RMQ. That's what
No,
the
no.
person.
I think so. Job acceptor responsibility is to. Uh, oh, okay. Instead of ingesting jobs. Okay, I think I got that. So, yeah, job acceptor is persisting the data in the HBase first and then sending an acknowledgement back, right? And
Right.
then job extractor is responsible for extracting the job back from the HBase. So the point I think the person is missing is key. These are two different things. Why? Because this can work. Like whatever he has suggested can work if you want to job, if you want to execute the job immediately. Let's, for example, I want a push notification to be delivered immediately. Yes, for in this case it can work. A client can just say that I want to just push a notification. In this case, the job acceptor we just push it to RMQ. But it's not our case, right? We have to schedule a job in future. Like for example, if somebody is saying I want to schedule a job after 1 week, right? So if we are directly pushing that message to RMQ, then what you are doing is you're just adding additional load to RMQ, right? And then it does not work, because how will the RMQ consumer know? Because once you have immediately pushed a message to RMQ, then the consumer will immediately consume it, right? But that the callback was supposed to be executed after, let's say, 1 day or 2 days, something like that. How will you prevent that? So this is where the job extractor module comes into place. Its responsibility is to actually find the list of eligible jobs that are present, and then once it has determined that this job is eligible, then only it pushes the message to RMQ. This is why we need a man in the middle, which is the job extractor module. So I think that answered your question.
Yeah, I think that's the end of the list. Let's continue with your further
Sure.
part.
All right. So coming back to the leader elector. So one of the let me zoom. I think yeah. Okay. Yeah. So at any given point in time, there are multiple instances of our application service are running, right? So now one of the question that can come, which I think nobody asked, is if there are multiple instances of job extractor module running, right, and they are querying the same HBase, what will happen? Because you want to execute a job only once, right? But if let's say there are multiple pollers running and they are running the same scan, hey, give me the job between list of job IDs between last 1 minute, right? So but they will get the same IDs, right? There can be concurrency issues. So how we are achieving scalability and how we are avoiding this kind of concurrency issue, right? So this is where the leader elector comes into place. So let's say let me go to whiteboard here. Yeah, let me go to whiteboard. Let me remove all this. Yeah, let me, yeah. So let's say we have three instances running for simplicity's sake, right? This is instance one, this is two, this is three, right? So and this is our zookeeper. So we use zookeeper for coordination. Zookeeper, for the folks who are not aware, just to give you a brief background, zookeeper is, as the name suggests, is the keeper of zoo, right? Like you can, like, it's a very funny way, but yeah, like this is where like the original authors actually also designed, like they told the name zookeeper, because distributed systems is like a zoo. Anything can happen and anything can go wrong. In order to maintain consensus among distributed systems, you need some kind of an orchestrator or some kind of a system that can bring some kind of peace to the zoo. And this is where the zookeeper is, right? So it, given our scale and given our distributed nature, we rely heavily on zookeeper to achieve consensus. And how do we do that? I will explain that. So for example, if we have three systems running, and let's say this is just for one client, right? So I can call this client as, let's say, x, client x, right? Client x. So, and let's say client X has some kind of partition. Let's say we determine three partitions to the client. This is done at some time of client onboarding, right? So, given, for example, it's very similar to, like, so the folks can relate. Like, for example, you come to EC2, right? And when you provision any EC2 instance, you specify, right, how many core you need, how many RAM you need, how many disk you need, right? Or you specify your requirements. So, similar to us, since we are a platform, internal teams come to us and say that, hey, this is our requirement. We want to schedule jobs at 100k RPS, or we want to schedule jobs at, let's say, 1000 RPS, right? So each client is different. So and since each client throughput is different, we partition them accordingly, right? So it does not make practical sense to do the same kind of partitioning logic that a 100k RPS client will deserve versus a client that has only 1000 RPS will deserve, right? So our partitioning logic comes into place when a client onboarding happens, right? So let's say a client comes in and say that I want to schedule it based on 100k RPS, or let's say 100 RPS for now, and based on our some internal rough calculation that okay, how much scale a single partition can happen, right? So we determine a fixed partition logic. Let's say we went with 3. So what happens is, whenever a job happens, right, like yeah, whenever a job happens, let's say we assign a job ID, right? Job ID. So job ID is the client acceptor module, right? Whenever its responsibility is to, take in this request from the client and persist the details in the HBase, right? Whenever that information is persisted, we also randomly generate a job ID and return back to the client. So this is our unique identifier for that job. Then we specify, some kind of partition one, then timestamp. This is our key. This is our primary key or row key in terms of HBase. I'm not going into specific terminologies. You can imagine it's a key, right? And then this is our logic: job ID colon partition ID and uh, timestamp, right? Uh, so okay, or let's call it. Sorry, where is the delete one? Yeah, sorry. Okay. So let's call it client ID, partition ID, and timestamp, and then job ID. So this is our key, and I will explain why this is important. Why are we storing partition ID? Why are we keeping timestamp ID and everything in the key? So this is our key, and then this multiple instances are running. So whenever an instance comes up, right? So Zookeeper, it registers that instance. Instance is registered with Zookeeper, and Zookeeper responsibility is to assign a leader. We not sure. I don't think folks are aware. Let me go back and explain what is leader election in Zookeeper. So there are three instances, right? So there are multiple ways of approaching this problem. It can so happen that each instance can determine, hey, either they can do themselves some kind of a gossip, like, okay, hey, what are you working with, what is your range, and they can try to do some kind of an gossip, like protocol, like, okay, they can discuss internally and try to see, try to work to achieve a consensus. But and there is other way in which there can be a leader based election, in which there can be a single instance that is responsible for assigning the partition, and this is where we went with. So let's say there are multiple instances running. One instance is delegated as the leader. And how is that instance delegated as the leader? You implement Zookeeper leader based election. That's a standard recipe, I would say, to implement a leader. I'm not going to how are we actually doing the leader based election in Zookeeper, because that will just take a lot of time. But just for now, you can assume that one instance is the designated leader, and its responsibility is to assign partition. So for now, let's assume that two instance becomes the leader, and then it says that, hey, I am the leader for client X, right? Then it will check, okay, client X is how many partition? Three partitions, right? So then it will check, okay, how many workers are registered? So it will check, okay, there are three workers registered, one, two, and three. Then it will assign that I have three partition, three workers. So based on round robin, it will assign the partition. So it will assign, let's say, partition one to worker one, partition two, worker two, and partition three to worker three, and that's it, right? So now what it will do, whenever a partition is assigned to each worker, they have watches set up on Zookeeper. So Zookeeper is allows to set up watches. So it's you can imagine it's kind of a notification service, not a notification exactly, but loosely speaking, it's a notification. Clients can set up a notification on a specific path or some kind of a node that they are watching. It can be something like key. It can be an ID that is associated to that worker, right? So let's say the ID of worker one is something, some random ID that has been generated, and it will, if somebody is doing anything to that node, it will get notified. So this is a kind of a signaling mechanism. So this is again leveraging Zookeeper internals. So folks who are not aware of Zookeeper, it might be some kind of an, there will be some kind of gap. But for now, you can imagine it's kind of a notification that they receive. Ki, hey, I am getting a trigger on a specific ID, and then whoever is the listener associate that has been registered on that ID, they will get the event. So the leader comes in, it assigns the partition to each instance, saying that, hey, you will work on one, two, three, and then each instance, what they will do is they will run a continuous scan based on their assigned partition. So for example, if the instance one was assigned partition, and so what they will do is they will run a scan on client ID. So client ID was X, then partition ID was 1, timestamp was dynamic. So for example, current time is 3:41. So they will run in start, like they will make an start at, they will do an start on this and the stop on this. So the stop key would be X comma 1 uh, comma timestamp. So let's say 3:41. This is will be in again bytes, like we will serialize it to bytes, and just for reference I am giving. And this is a scan it will do, right? Start X 1 3:40. Now the beauty of this is an regex you can imagine. So HBase supports this kind of an scans. Okay. Now, whenever you run any kind of an scan on HBase, it will provide me all the keys that matches this filter, right? And so we will get all the values, all the job IDs that are present on this partitions, or between this timestamp, right? Okay, for this client ID and this partition ID, between this timestamp, what are the job IDs that are eligible? So let's say we received 1,000 job IDs, right? 1,000 job IDs, and you can imagine this is happening in parallel. So 1,000 job IDs are for one partition, and this instance 2 will also be running the same query, but for partition ID 2, right? And for same third instance will also be running, but it will be running on partition ID 3. So this is the way we are achieving scalability. So if there are three instances running and three partitions, so we are able to achieve scalability using this logic. So I have covered a lot. Let me take a pause here. Feel free to ask any questions that you have.
So, folks, if you have any questions, put them in the chat. Right now, there are no questions. I hope everybody is alive. If you need a break of a minute, you can go back and have some water. But yeah, if you have any questions, if something was not clear, um, feel free to ask it. I would request Snehasish maybe to explain it again. But do post your question in the chat. I think there is one, which is there any partition reassignment for a client if suppose
Yes.
the clockwork instances need to outscale?
Yeah, that's a very good question. For example, let's say if a fourth instance comes up, right? So Zookeeper, like the leader, is responsibility is to set up watches on a specific client, right? So or workers, right? So it keeps track of the eligible workers that are present. So if it knows that, okay, there are currently three workers. So if let's say one worker goes down, right, or a new worker comes up, so it knows that a new worker has come up, and it will do a partition reassignment strategy. So it will again, trigger the reassignment. So, for example, currently, in case let's say there are three partitions only, and let's say there are 100 workers, so it does not make sense, right? Because it has already assigned, let's say, three partition. But let's say the third partition that was assigned to third instance went down, right? So then it will know that, okay, third instances went down, how it will get notified? Zookeeper will push a like, set a watch and set a trigger notification to the leader, and then leader will check, okay, something has went down. So what it will do, it will again do find all the list of workers that are present. So it will check, okay, one is present, two is present, four is present, right? Then it will again do a partition reassignment. It will trigger, okay, you go and handle one, you go and handle two, and you go and handle three. So this is where the rebalancing happens. And let's say, more instances are present, and let's say a heavy client is there and it has 100 partitions, but let's say there are 25 workers only running. So each worker will get four partitions at any point in time, right? So let's say we are not able, there is some lag that is building up, so we can add more, we can is auto scale new instances, and the leader will get notified, and it will trigger a partition reassignment strategy. So each instance can get more partitions or less partition if and when required.
Now
So I
that
hope that answers the questions.
yeah, the interesting questions coming up. Um,
Okay.
what is the logic behind partitioning?
What is the logic behind partitioning? Yeah, so I explained it earlier. It's just a way of achieving scalability, right? So if let's say a client comes and say that I have 100 schedules, my requirement is only 100 RPS. Like I want to schedule only at 100 RPS. So we say that okay, fine, then only two partitions can work, right? Because we have some kind of rough idea that a partition can achieve. Because see, we for each partition we are running an HBase scan, right? So if let's say an scan is giving me 5,000 jobs per scan, so we know that a partition can easily support 5,000 RPS, right? So but a client has said that for 100 RPS we need 100 RPS, so we still give two partitions because we want to achieve fault tolerance. For example, let's say there if there one instance goes down, then again the rebalancing can happen, but for during that time it can so happen that okay, no callbacks are present given to the client. So we minimal is two, but let's say we increase it as and when clients provide their requirement that my schedule RPS is 1,000, 10,000, 50,000, 1 lakh and all. So based on those, we increase more partition. So just the TLDR is each partition can work on a specific scale only. So for example, 5,000, right? It can one thread can do 5,000 scans per partition. So if a client has 1 lakh requirement, 1 lakh schedule as a requirement of scheduling 1 lakh jobs per second, we at least give him 20, 30 partitions so that it can scale as much as one.
I am getting a follow-up question on this. Sorry if I missed it during the conversation. I was just managing some chat also. So
Okay.
are you maintaining one partition? Meaning one partition is sort of is responsible for only one client, or are you sharing the partitions for clients? I'm not sure if I
Yes.
missed it earlier.
Yes, that's a fair call out. I have mentioned it. If partition is specific to client, so
Okay.
client ID, partition ID. So let's say there is another client, right? Like client Y. So let's say there is client Y. So it will have its own partition. So let's say client I has RPS of 10,000. Let's say 10,000 RPS. So we have let's say allotted him 10 partitions, right? So
Understood.
when a client will schedule a job, it will the 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 row key that it will generate is Y, and then the partition ID will be one, and then timestamp and all. So and each instance will be responsible for some client and some partitions, right? So it can so happen that let's say there are three instances running and there are two clients, right?
Right.
So one client itself, this instance is running. So let me write it down so that it so one instance will be responsible for X client X, and let's say partition one,
Hmm.
and then one is responsible for client Y, but let's say partition two. This is all done by the leader,
Hmm.
right? Partition reassignment. So two will be client X, partition two, client Y, partition one, and it can be so the first client can be the leader for client X, and two can be the leader for client Y. So everything is independent. Each clients are independent. Each partitions are associated with that client only.
Understood. Thanks, Nancy. Let's go to the next question. Who is so okay? What happens when zookeeper goes down?
Yeah, so Zookeeper is that's a fair call out. We run, that is why we don't run a single node of Zookeeper. Zookeeper has a quorum. right? It's again a distributed system in internally, like it has their own quorum. It uses Zookeeper atomic broadcast to achieve consistency. It's a strongly consistent system. So we run, 3 to 5, generally odd nodes are run, like 3, 5, 7 nodes are run. So we run with 5 nodes, 7 nodes system cluster in production. So it's very rarely that all the 5 nodes can go down. It can only happen if the entire data center goes down. Again, the probability is very less, but yeah, if Zookeeper goes down, then our system won't be able to. And like it can work, it will continue to work as long as there is no rebalancing. Like for example, as long, because this is only like Zookeeper responsibility is to just set up the partition assignment, right? Like this Zookeeper, like when a new node comes up and new node goes down, right, an additional node goes up and goes down, then the leader gets notified. But let's say system is stable, there is no node addition, no deletion happening, then we don't interact with Zookeeper. Only Zookeeper interaction happens when we are scaling up or scaling down. So let's say Zookeeper went down, but then we won't be able to scale up or scale down. So that is a limitation, but yeah, that's a very that can happen very rarely.
Cool. Let's go to the next question, which is partition size fixed? That is, all partitions are of approximately same size,
So I think by same size, he meant by the question, they meant is probably the number of jobs that
right?
the job extractor module is returning. So yes, it's each partition is fixed. That is responsible for getting, a fixed number of jobs from the HBase, or running the scans on a HBase on a specific fixed time interval. So it's fixed. But yeah, if your question is key, is each client allotted the same partition? No, each they are allotted the partition based on their throughput requirement.
Right. So the next question is, oh, sorry. Yeah. Can you explain how job extractors are assigned and invoked for each client?
Okay, how job extracts are assigned. So yeah, so this is, I think, folks are having confusion with, but yeah, like it's we heavily use Zookeeper to do all this kind of coordination system in place. I have written, like I can give a link to the repo that is present on my GitHub, that mimics the way you can run your own job scheduler platform using Zookeeper. But going into deep dive, like if you want to just take a TLDR, is we use leader based election on Zookeeper to kind of do this coordination. There is a single node that is allocated the leader, and then the leader keeps track of the workers that are available. Let's say there are 3 workers, then it knows, okay, how many partitions are there, and it assigns a partition to each workers in a round robin manner. But how this actual code is written, then you have to actually see how to leverage Zookeeper leader based election. For that, I can, at the end of the talk, I will give a link to my GitHub repo, which actually and using that you can actually create your own job scheduler platform just by using Zookeeper. So it's a very lightweight repo, and you can use it as a good stepping stone to learn about Zookeeper.
Makes sense. Thanks, Snehasish. Let's go to the next question. Isn't the throughput of a partition limited by the slowest callback of a client?
Isn't the throughput of a partition? No, no. So this is where we have decoupled the module, right? Like job extractor and RMQ publisher. So this question will it's valid only if you are extracting from the client from the HBase and pushing to the and making an HTTP callback in the same thread. But we don't do it, and this is the reason why we don't do it, because they are completely independent. We don't want to block our scans just because we are making an HTTP callback, and that can take a lot of time. So this is why the scanner thread just immediately scans from HBase, and then the eligible jobs are pushed to the RMQ and one go, right? So this is independent, and then there are independent RMQ consumers running, which are independent separate threads that are running, and their responsibility is to make an HTTP callback. So that can take long, right? Like it can go at its own pace, but the production can go at its independent pace, right? So we are not blocking. We don't care if, let's say, if a client has, even if a client is dead, we like I will come back to the RMQ consumer part, but even if a client is dead, the production won't hamper.
And that consumer of RMQ takes one by one, right?
Yes, yes.
Okay.
it has its own pool and all, like they like the way they can also achieve, scalability. But yeah, its RMQ publisher is not in fact blocked with RMQ consumer. It can go at its own pace.
Right. Cool. So this is another question from Siddharth. So this partition is in HBase.
Mhm.
Does HBase gives the API to query on certain partition, or is it something else like a client ABC comes and call 500,000 jobs? What will happen?
Okay, yeah, that's a good question. So this partition is not in HBase. It's in kind of an application level sharding that we have done, right? So there is no partition, there is no native functionality in partition in HBase. So we have designed our rookie such that we can leverage HBase to give us all the jobs that are between a specific time lane. So that is why we are doing a scan. So for simplicity's sake, like if you want to relate with MySQL terms, like you can imagine you are doing kind of an where clause, right? So partition ID, you can imagine it's a separate column. Let's say, for example, you don't want to use HBase, and let's say you want to use any MySQL database. So the way you will do it is you will have a table or a schema which has your column will one column will be client ID, another column will be partition ID, third column will be timestamp ID, and fourth column will be job ID. And your workers will run and they will make an query on your MySQL database saying that, hey, give me all the job IDs, select job ID, form table where client ID is equal to X and partition ID equals 1 and timestamp is less than or equal to between a specific range, right? So if you have to relate to in MySQL terms, then partition ID is a application level sharding that we have done. I think that answers the question.
Yeah, I think that's the last question in the list. Let's
Okay.
proceed further.
Okay. All right. RMQ publisher, right? So once the list of eligible plans is fetched and some validations are performed, right, we push all those messages to RMQ, which acts our messaging broker. And this is where the decoupling takes place. We don't want to block our actual HTTP callback, and we don't want to block our scanner threads with the callback. So this is why we have to decouple the publisher and the consumer using a queue. So any queue can work. Kafka, Pulsar, or RMQ, Apache, any queue that you want to use can work, but you just want to decouple the publisher and the consumer. So there is one challenge is the rate limiter. I will come back and how we have achieved operational excellence. This is the way we have achieved operation, and I will come back to it. Right. Um, Coming back to the RMQ consumer. RMQ consumer is just listening to the incoming message in the RMQ queues and executes them by making an HTTP callback to the specific URL endpoint. And any failure, let's say the client is down or it is taking more time than expected, right? Based on the timeout setting that we have done. So then we push that message to a sideline queue. So sideline queue is again a functionality that RMQ provides. It's a dead letter queue or a failure queue that you can imagine that all the messages that has failed is present here. But before pushing that messages to the dead letter queue, we do internal retries based on the client policy, because some clients don't even want retry, right? So it's again based on the client policy what they want. Some clients can say, hey, I just want to drop the message in case the failure has happened, or they can say that, hey, I want to retry the message, exponential back off, or 2 times, 3 times, 4 times, whatever. It's up to them to provide us their policy, and we will execute retry based on their policy. So if they say that I want to drop the message, we won't do any retries. We will just call once. If the failure has happened, we won't do any retry. But if let's say client wants I want to do sideline the message and retry based on a specific policy, we retry it couple of times and then sideline it or push in a dead letter queue until and unless and then just then that's it. So then we have some APIs that clients can invoke to manually move the messages from sideline queue to the main queue in case their APIs is recovered. So why that is important is because let's say a downstream is having some issue, their service is not up or they're having some production issue. So this issue can happen for run for let's say half an hour, 1 hour, 2 hours, 3 hours, something like that. So we can't keep calling them again and again, because it's kind of a circuit breaker mechanism, right? If you know your client is having some issues and is not able to make a call, we should not retry them again and again, because it's will just increase the pressure on the clients itself. So it's this silent access circuit breaker mechanism. So we actually stop making callback to the clients if, let's say, the size of the queue increases beyond a certain threshold. So let's say we have a threshold of 100K, and again, it's client is specific. So clients can say that, hey, I want to increase my threshold or decrease my threshold. But let's say a client general threshold, default threshold is 100K. So if the amount of messages in the queue increases beyond 100K, then we just don't push the messages to the RMQ. We just stop scanning, because it's kind of a back pressure propagation if you think of it this way. Because we know clients is having a bad day, then we should not keep calling them again and again, and we should also not keep doing our HBase scans, because it's just kind of a waste, right? Because we know, even if we push our messages to from the like even if we consume our messages from HBase and push to the RMQ, then we can't do anything. Our queue of the RMQ itself will go, we will keep on increasing, and that can increase load on our RMQ cluster. So in order to prevent our cluster from going out of memory and prevent unnecessary load, we implement all this circuit breaker mechanism to help ourselves, right? So yeah, I think I have covered all the modules. Let me know. And I think the question that I had is, somebody asked, is retry. I think I covered retry as well. And let me know if I have missed anything, or you want to go into anything else.
Yeah, I think we have covered most of the things. There are no questions in the chat also. If anybody has any question, put them quickly. We'll take it. Yeah, I think there's one more question that's coming up. Won't using Kafka would have solved this back pressure problem without any rate limiter. It works as it works on pole-based mechanism.
Yes, yes. So every system has its trade-offs, right? You have to understand the trade-offs, right? Yes, you are right. Ki if we have used Kafka, then back pressure mechanism would have been solved. But the challenge with Kafka is it's a very operational heavy, right? Like it's not typical. Like if you have a Kafka cluster set up already in production that your team is using, then then it's good. But let's say if your team does not have a Kafka cluster, then setting up a Kafka cluster requires, let's say, Zookeeper. Like it's in the older version that, yes, but still you will require a Zookeeper. You will need a Kafka cluster. You will need to set up some kind of an monitoring, alerting, and everything. But since we already had RMQ in place, then we went ahead with RMQ. So it's all about, see, in any kind of system design, you have to be agnostic about the trade-offs that you are making. There is no correct answer for any design. So many folks can come and say that, yes, you could use that, this and that, and it's absolutely correct. We could have used that, but the point is you have to understand the trade-offs. If you know, if your business agrees with the trade-offs, and if you are, then it's well ahead and good. But since in our case we didn't have that Kafka cluster at that time, we went ahead with RMQ because it's very operational light. We just need 5 nodes and that's it.
Makes sense. Another question from Rizwan. Does this system also supports recurring jobs or only one-off scheduled jobs?
Yes, yes, that's a fair point. We do support recurring jobs. Recurring jobs, for the folks who don't know, is something like repeatable. Like in a cron tab, like you can say that I want to run a job at every 5 p.m. every day, right? So yes, if whenever a client comes, and they can just say that the repeatable policy. What is the time, or when is the day they want to repeat the job? How many times the start time, end time, right? The frequency they want to receive. Yes, in the interest of the explanation, I didn't explain it, but yes, the implementation detail is very similar. For example, if let's say you want to do implement a recurring job, then what you can do is since you have pushed the message to the RMQ of this job extractor module, right? So it knows that, okay, this is a repeatable job. So then immediately after pushing the message to the RMQ, and after deleting, it can insert a new entry in the database internally, right? Ki, okay, this is a new entry that I have to insert based on some like current time is this, and somebody is saying ki, I want to schedule a job after 1 week. So it will insert a new entry in the database after with the timestamp after 1 week. So it can be handled internally.
Sounds good. I think that's about it. People are, you know, asking like, do you have any plans to open source this?
So
And
yeah, it's actually, yeah, like it. I'm not sure. It's an internal company product actually. So we have to explore this option.
yeah, and another person is asking about that GitHub thing that you mentioned, right?
So let me. Actually, I don't know how to share this, but like, I'm
You can
like.
just ping it to me. I'll maybe put it in the
Oh,
chat
okay, okay. Like, I pinged you. Okay.
on LinkedIn.
Yes, yes.
Okay, just a minute. I'll take it from there. Okay, so I'm putting it in the chat, and cool. I'll also what I'll do. I'll put the link of this repo in the description of the video. Also, I think that's about it. Thanks a lot, Snehasish. I think that was a very insightful session. How do we go about building such kind of products in companies? I think very scalable and interesting product that you have got a chance to build up from scratch. Yeah, I think as I said in the beginning, also if anyone of you wants to connect one-on-one with him, do check out his Engine Buggy profile. I've already put the link of that in the chat. Also in the description, I've put it. I hope it was useful to you also, and yeah, give a shout out to Snehasish or to me on LinkedIn or maybe in Genbogi, anywhere. If you like it, do subscribe to the channels. Do subscribe. Do like the video, and if you have any question even further on, put it in the comments. I'll try to connect with Snehasish. I mean, I don't know if you all know or not, but Snehasish and me were in the same college, so that's how I know him. Yeah, but yeah, thanks a lot, Snehasish, to you also. For taking out for taking out so much time and walking us through all of these details. They were really helpful. Yeah, I think then we are good. Thank you all for joining. I'll see you in the next video. Bye.
Yeah. Thank you, everyone.